So welcome to the next video in our PIC16F84 PIC microcontroller series of videos. And in this simple video, I want to look at how we might connect or interface a LED to the PIC microcontroller. When I've explained how I'll interface or connect one LED to the PIC microcontroller, I'll then look at how I can connect a series of 8 LEDs to the PIC microcontroller. And that's all shown on page 5 here. So let's have a look at the PIC16F84 microcontroller. Here it is here. This rectangular shape represents the microcontroller. And I want to connect a LED to pin line or port line RB0. Now the port B lines are always used as outputs in this particular module. So RB0 is going to be an output line, and I want to connect it to this LED, and I've called the LED D0. I can't connect port line RB0 directly to the LED. I always have to have this 330 ohm current limiting resistor, which I've called R here, in series with the LED D0. If I don't have that, too much current will flow out of the PIC microcontroller through the LED, and either the LED will blow or the PIC microcontroller will blow. So anytime you ever see a LED, you'll always have this current limiting resistor R in series with the LED to make sure that too much current doesn't flow through the LED and blow the LED, or even worse, blow your microcontroller that's connected and controlling the LED. So in this particular case, pin 6, which is RB0, is connected to LED D0 through resistor R. I note the D0 here is a LED because I've got these two arrows up at the top here, and these two arrows represent a light emitting diode. If they weren't there, we'd have a problem. We'd be using an ordinary diode. So make sure when you're drawing your symbol for your LED that the two arrows are there, indicating that it is a LED. So our LED is now wired or interfaced or connected to RB0. And you can see I've got ground out here. Now that's the same ground I've connected to the PIC16F84 microcontroller. So what's going to happen here, folks, is if I put a logic 1 or a high or 5 volts on line RB0, this LED here will turn on, so D0 will turn on. And if I put a logic 0 or low on pin RB0, this LED here will turn off. So I can turn the LED on or off by sending a logic 1 or a logic 0 or a high or a low to these port lines, RB0. So that's how you connect one LED to line RB0. Port B actually has got 8 lines called RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7. So what we can actually do is repeat this circuit, this resistor LED circuit, 7 more times as shown down here, and connect RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7 to 8 LEDs. And the LEDs are called D0, D1, D2, D3, D4, D5, D6 and D7. If I send a logic 1 and out on any of these port lines, the LED will be on. And if I send a logic 0 out on these port lines, the LED will be off. So logic 0 has been sent out here on RB7. So this LED here is off. Logic 1 has been sent out on RB0. So this LED is on. Now inside, in my PIC microcontroller, I have 2 registers. I've got the port B register and I've got the TRISC-B register. For this arrangement to work, I need to load the TRISC-B register with 8 zeros, and then I can send logic 1s and logic 0s to the port B register to turn the individual LEDs on and off. I'll explain more about the TRISC-B register and the port B register in our software notes, and there'll be a short video on that as well. So really what's happening is any data that's contained in this port B register is passed out onto the pins and then is displayed on the LEDs. And that's how I can connect 8 LEDs to port B of my PIC microcontroller. Let's now look at how I can connect some switches to my port A. So at the top of this page here, I've got one switch called SW. It's a push button switch, and it's connected to line RA0. So that's port A, line RA0, or pin 17 if microcontroller if you prefer. What happens here, folks, is normally this 10k resistor pulls that pin 17 high. But if I press and release this switch, I'll send the logic 0 in on RA0. So by pressing and releasing this switch, I can send either a logic 0 or a logic 1 in on RA0. So that's how you interface the switch. It's very straightforward. You basically have the switch pressed or not pressed, and you send the logic 1 or a logic 0, high or low, in on RA0. Now, there's two types of switches. This is called a push button switch. Down here on this part of our slide, I've got on-off switches. Now in this case, I've got 4 on-off switches. I've got switch 0, switch 1, switch 2 and switch 3. And they're connected to RA0, RA1, RA2 and RA3. At the moment, these 4 switches are open, and that means that the lines RA0, RA1, RA2 and RA3 are all tied to 5 volts through these 10k resistors. If I close this switch, I will connect RA0 to a logic 0 or low. So that RA0 inside here in the port A register will change to a 0. So that's how you interface 4 switches to port A. And you can see I've got RA4 tied directly through this pull-up resistor to 5 volts in this arrangement. RA4 in fact is not being used in this circuit, and if it's not being used, you have to tie it to a logic 1. There's a rule in digital logic that all unused inputs must be tied high. So RA4 in this application is tied directly to 5 volts through this 10k ohm resistor here. We've only got 5 port A lines, RA0, RA1, RA2, RA3 and RA4. We don't have 8, we only have 5. So that's why I've only shown 4 switches here and RA4 tied directly to 5 volts. Once again, I've got a port A register inside in the PIC microcontroller and a tris A register inside in the PIC microcontroller. So internally in the PIC16F84, there are 2 registers. One is called a tris A register and the other is called a port A register. Now the tris A register has to be loaded with 8 1s if we're going to connect input devices to port A, and the port A register will contain the logic levels on these 5 lines here. So any logic levels or any logic changes that happen out here will be reflected inside in the port A register. And again, I'll talk more about that in my software videos. Okay, thanks for listening folks, that's the end of this video.